Just a reminder about this y equal to minus 1 over x, which is the reflected hyperbola about either the y-axis or the x-axis of the hyperbola y equal to plus 1 over x. It has exactly the same domain and exactly the same vertical and horizontal asymptote, and it has exactly the same lines of symmetry. Y equal to x is a broken line here, and y equal to minus x is a broken line there. But in this case, we will be in the second and the fourth quadrant, because in the second quadrant we have negative x but plus y's, so it results in a negative. If I put a negative in here, I will get a positive answer. If I put a positive x in here, then I'll get a negative answer. That's why it's below the x-axis. What I just said now about the graph, this is now algebraically written out. Remember that x and y are inversely proportional to each other, so the product of x and y must be negative 1. Therefore, if I have a minus x value times a plus x value, I will get a negative value, and if I have a plus x times a negative y, I will also have a negative answer. And that's why we land in our second and fourth quadrants with our hyperbolas. The rest, let us now consider our function y equal to r of x, which is x minus 1 over x minus 2. Note that r is not in the standard form. Remember, we said the standard form is this y equal to k over x minus b plus q. And the cases that we are now considering is we're looking at k negative values. That's why we are now in the second and the fourth quadrant. If I go back to my function y equal to x minus 2 over x minus 1, then I have to write it in standard form. The easiest way to do that is I take the denominator stays the same, then I write x minus 1 on the top also. In this case, I can rewrite the x as x minus 1 minus 1 like that. There's nothing else there. So in the numerator, I have got x minus 1 minus 1. Now I split the fraction to x minus 1 over x minus 1 plus minus 1 over x minus 1. I can write r of x now as minus 1 over x minus 1 plus 1, and the plus 1 comes from here where I've cancelled my x minus 1 divided by x minus 1. So my denominator, which is x minus 1, may not be 0, so x may not be 1. In this case, my k is negative 1, which is less than 0. My p is plus 1, which is positive, and my q is equal to 1, which is positive. And immediately, because of k negative, I can put it in the second and the fourth quadrant because of the k negative value. I will have my domain everything except 1 because of the p value, and everything except plus 1 for the q value. Remember that this part here can never be 0 because the numerator cannot be 0. So I can never have a value of plus 1 for my y. So from my p value, my vertical asymptote will be x equal to 1. And from my q value, y equal to 1 is my horizontal asymptote. To write down the axis of symmetry for the regular one, we have a plus x and a minus x. But now our x in this case is the whole denominator, which is x minus 1, x minus 1. And then I just add my q values. And if I simplify, I get x and that. But in this case, you can see that the lines of symmetry shift one to the right and one up. We've done that with the straight lines, one to the right and one up. And the same with my hyperbola. Because of my form of my R of x, we can see p is positive, so the red graph will shift 1 unit to the right and 1 unit up. And on the graph we will see red broken lines, but it's the two slanted lines. The vertical and horizontal asymptotes are also red broken lines, but you will distinguish it easily from the lines of symmetry. Let us look at the x-intercept. I have r of x equal to x minus 2 over x minus. We will have the x-intercept whenever y is 0. So the whole fraction here must be 0. And that will only happen when the numerator, which is x minus 2, when that is equal to 0. Because x minus 1 may never be 0. So that will happen when x is equal to 2. So x equal to 2 is my x-intercept. And my y-intercept, I must just substitute x equal to 0 in the formula here. Then I get 0 minus 2 divided by 0 minus 1. And that will result in a positive 2 value. So I have an x-intercept of 2 and a y-intercept of 2. I'm going to transfer some of this on the graph so that we can discuss the graph. I've just labeled the broken green lines. Here we have the line of symmetry, one of it, y equal to plus x. Here we have the other one, y equal to minus x. This is the second quadrant, y equal to minus 1 over x. And here I have my fourth quadrant, y equal to minus x, the green broken lines. So we know that this, my r of x is equal to minus 1 over x minus 1 plus 1. So I have a p equal to 1, which is positive. I have a q equal to 1, which is positive, but my k is negative 1. So I know I'm in the second and the fourth quadrant. So let us look first of all at the role of this minus 1p. If I ignore q equal to plus 1 and I only look at the x minus 1, then we see it is this graph, y equal to minus 1 over x, shifted 1 unit to the right because my p is positive. So from b we will shift to that point there. From B it looks like the point I. From A we will shift to the point J, and that is 1 unit. But the Q equal to 1 causes this point I to move 1 up. So I can say to get to K I must move 1 to the right and 1 up. And to get to L, I must move 1 to the right and 1 up. And to get to one of the lines of symmetry, I can take any point. I must move 1 to the right and 1 up. So in this case, I started at x equal to minus 2, y equal to 2. And I ended at x equal to minus 1, y equal to 3. If I look at my other slanted one, I can take, for instance, here at minus 2, I can say 1 to the right and 1 up. My vertical asymptote also shifted 1 unit to the right because vertical only consider the x's, and horizontal also shifted 1 unit up because of the q value. We can just write a r on the red graph to label it. From this p and q value, let us find the vertices k and L. So k will be, start at negative 1, then we plus 1 in the x direction, and the y we started at 1 and then we plus 1 in the vertical direction. So we will get k equal to 0, 2. And this is exactly the point also the y-intercept of my graph. To get to the point L, I can say L, we started at 1, then we move 1 to the right, and then we have the y value -1, and then we plus 1 for that. So L will be 2, 0, which is incidentally also the x-intercept. In this case, the vertices of this red graph R coincide with the y and the x-intercept. It is not always like that. So if I have my green graph, if I have my mother graph or the reflected mother graph, then it's very easy to just look at my P and Q values and then move the graph, move the lines of symmetry and the vertical and horizontal axis. Here, this vertical line has an equation of x equal to 1, and this horizontal asymptote has an equation of y equal to 1. We can only see a clear picture like this if we have graph paper. I've used software to draw the graphs. By hand it's not as easy, but what you must note is the purple graph and the red graph will never cut each other. The green graph and the red graph, they intercepted as well as here in the fourth quadrant, and we can work that values out and see what we get for that, but there's no significance in this case why they are intercepting there, except when we ask questions like when is the one larger than the other, whatever.